Ever looked up at the sky and imagined clouds of iron? Not water, but actual iron. And when it rains, it's not gentle drops, but a downpour of molten liquid metal. Sounds like something straight out of a wild sci-fi movie, right? Well, this is the real deal daily weather forecast on an exoplanet called WASP-76b. It's a place so incredibly hellish, so utterly alien, it makes the most extreme spots on Earth look like a walk in the park. So get ready, because we're about to take a trip 640 light years away to a world where the sky literally weeps iron. Our destination, WASP-76b, is out there orbiting a star in the constellation Pisces. Found back in 2013, this is definitely not your friendly Earth next door kind of planet. It's what astronomers call an ultra-hot Jupiter. Picture Jupiter, our own gas giant. Then imagine dragging it super close to its star. WASP-76b is snuggled up to its star, which is a bit bigger and hotter than our Sun, about 12 times closer than Mercury is to our Sun. Because it's so close, it whips around its star in just 1.8 Earth days. That's one full year there. Now, when a planet gets that cozy with its star, something pretty interesting happens. Tidal locking. You know how our moon always shows us the same face? Same deal with WASP-76b and its star. This means one side, the day side, is stuck in never-ending scorching daylight, while the other side, the night side, is in permanent darkness. And this is where WASP-76b's truly mind-blowing weather really gets started. The day side is blasted with thousands of times more radiation than Earth gets from the sun. This intense heat puffs the planet up, making it nearly twice as wide as Jupiter, even though it has a little less mass. If we could somehow get close to WASP-76b, the first thing we'd notice is just how ferocious its day side is. Temperatures there skyrocket to an unbelievable 2,400 degrees Celsius. That's around 4,350 degrees Fahrenheit. To give you an idea, that's way hotter than the melting point of most rocks and even metals. It's so incredibly hot that things we usually think of as solid like iron just can't stay that way. On WASP-76b's day side, iron doesn't just melt, it vaporizes. It turns into a metallic gas, floating around in the planet's atmosphere with other vaporized bits of rock like calcium, magnesium, and even vanadium. Scientists, using some seriously powerful tools like the espresso spectrograph on the Very Large Telescope in Chile, have actually peered into this distant world's atmosphere. They do this by looking at the light from WASP-76b's star as it passes through the planet's atmosphere. It's a technique called spectroscopy. This lets them see the chemical fingerprints of these elements. And guess what? They found the signature of gaseous iron, confirming that the day side is a literal furnace hot enough to turn metals into gas. Imagine an atmosphere not of nitrogen and oxygen, but of superheated, vaporized rock. Okay, now picture the boundary between this blazing hot day side and the forever dark night side. This zone is called the Terminator, and it's a place of absolutely wild contrasts. The temperature difference between the two sides is huge. The day side is over 2,400 degrees Celsius, and the night side is a cooler 1,500 degrees Celsius, which is still incredibly hot. This massive temperature and pressure difference does exactly what you'd expect. It creates wind. And we're not talking about a gentle breeze. These are winds so powerful, they're estimated to rip around the planet at speeds up to 18,000 kilometers per hour. That's over 11,000 miles per hour. Way faster than the speed of sound here on Earth. These monster winds are key to WASP-76b's bizarre weather. They act like a giant conveyor belt, scooping up that vaporized iron and other elements from the superheated day side and dragging them across the terminator towards the cooler night side. Recent studies have even spotted these powerful iron winds on the day side, giving us an even clearer picture of this chaotic, swirling atmosphere. It's a relentless planet-wide storm of metallic vapor, all driven by that stark difference between eternal day and eternal night. So as this iron-filled atmosphere, supercharged with heat and moving at incredible speeds, travels over the terminator to the night side, things start to change a lot. Remember, the night side is still unbelievably hot by our standards, around 1,500 degrees Celsius, but it's a good deal cooler than the day side. For iron vapor, this temperature drop is everything. When the gaseous iron hits these cooler conditions, it starts to lose energy. The iron atoms, which were zipping around all freely in their gas state, begin to slow down and clump together. They condense. It's just like how water vapor in Earth's atmosphere cools and condenses to form water droplets. On WASP-76b, the iron vapor condenses into liquid iron droplets. And what happens when these droplets get heavy enough? You guessed it, they fall. This is the signature move of WASP-76b. It literally rains molten iron. Droplets of liquid metal glowing hot would pour down through the dark, stormy atmosphere of the planet's night side. Since WASP-76b is a gas giant, there's no solid surface for this iron rain to splash onto. Instead, these iron raindrops just fall deeper and deeper into the planet's atmosphere, eventually hitting hotter layers where they'd vaporize all over again, starting this hellish metallic weather cycle anew. The evidence for this iron rain is pretty strong. Astronomers saw the chemical signature of iron vapor on the evening side of the planet, where day turns into night. But here's the kicker. They didn't see this iron vapor on the morning side, where night turns back into day. This strongly suggests that the iron condenses and rains out during the night, basically scrubbing the upper atmosphere clean of gaseous iron before it swings back around to face the star. Now, some later studies have suggested other ideas for what they're seeing, like temperature variations, but the iron rain idea is still a very strong and fascinating possibility that fits a lot of the data. But WASP-76b isn't just a one-trick pony with its iron rain. Its atmosphere is a wild, complex chemical soup. Besides iron, scientists have found other elements like sodium, calcium, magnesium, manganese, and even barium. Take ionized calcium, for instance. Its presence suggests that temperatures in some atmospheric layers might be even higher than we first thought, or that there are incredibly strong winds whipping through the upper atmosphere. And recently, there have been hints of something else amazing. A glory. A glory is an optical effect, kind of like a rainbow here on Earth, that happens when light reflects off clouds made of perfectly uniform tiny spheres. Signs of this were spotted on WASP-76b as an unexpected increase in light coming from the planet's eastern terminator. If this is confirmed, it would be the first ever glory seen on an exoplanet. It suggests that even in all that chaos, there might be some kind of stable, uniform cloud droplets. What those droplets are made of is still a mystery, but it just adds another layer to how strange and fascinating this world is. Studying all these elements and atmospheric tricks helps scientists get better at understanding exoplanet atmospheres. They can learn about the kinds of exotic chemical reactions that can happen in places so incredibly different from our own solar system. Figuring out which elements are there and what state they're in, vapor, ionized, or condensed, gives us vital clues for understanding how planets form and change under extreme conditions. So why bother spending so much time and energy studying such a harsh and faraway world? Well, planets like WASP-76b, these ultra-hot Jupiters, are like natural laboratories. They let us test our understanding of planetary science in the most extreme conditions imaginable. They really push the limits of what we thought was possible for a planet. Discovering iron rain and potentially other crazy weather like gemstone rain on different exoplanets really shows off the incredible variety of planetary environments out there in our galaxy. Many of these worlds are far stranger and more violent than anything in our own solar system. By studying them, we get a much bigger picture of how planets form, how their atmospheres work, and the sheer range of conditions that can exist in the cosmos. Of course, with its scorching temperatures and metallic downpours, WASP-76b isn't exactly a holiday destination for life as we know it, but figuring out these hostile environments is really important. It helps us pinpoint the conditions that are necessary for life. By seeing what makes a planet uninhabitable, we get better at spotting those rare worlds that might actually be able to support it. Plus, the amazing techniques and instruments developed to study planets like WASP-76b, like high-resolution spectroscopy with tools such as espresso, are paving the way for even more discoveries. Being able to dissect the atmosphere of a planet hundreds of light years away from afar, that's a stunning achievement of science and engineering. These same techniques will one day be used to look for biosignatures, the chemical signs of life, in the atmospheres of more Earth-like exoplanets. The universe is just packed with wonders and, yes, horrors that are way beyond our daily experience, and WASP-76b is a pretty stark reminder of that. What other unbelievable planets do you think are out there just waiting to be found? If this journey to a world of molten iron rain blew your mind, be sure to hit that like button and subscribe for more explorations of the cosmos. And tell me in the comments below, what's the most extreme or bizarre planetary feature you've ever heard about? I'd love to hear your thoughts. WASP-76b, with its day side hot enough to vaporize metal and its night side where that same metal falls as a fiery rain, really shows you what the universe is capable of at its most extreme. It's a world that stretches our imagination and broadens our understanding of what a planet can even be. While we definitely won't be booking any holidays there, studying this hellish world and others like it keeps teaching us about the vast, diverse, and often violent nature of our home galaxy. Every new discovery, every decoded signal from a distant atmosphere, brings us a little bit closer to understanding our own place among the stars and the incredible variety of worlds beyond our own. The iron rain of WASP-76b is a dramatic, fiery reminder that the universe is far stranger and more wondrous than we can often even begin to imagine.